So let's go ahead and at least get started, give you some basics on what we're doing today, and also give you a little introduction to what the webinar concept is all about. So if this is your first visit to Creative Stage webinar series, we're pleased to have you join us, and we hope you find the information today valuable and that you'll join us frequently for future events. For those of you who have been with us before, welcome back, and thanks for returning. We appreciate your ongoing interest and are glad you found the previous webinars worthwhile. We've received a lot of encouragement from you and outstanding feedback, which is really helping to drive this series. And one of the things that we're definitely interested in and recommending is if you could please continue to give us your input. We're definitely looking to be very responsive to that in terms of planning of future events.
Kevin?
Yes. John, you're back.
Yes.
Okay. All right, so I went through and we started doing a little brief intro here. I'm assuming that right now everybody can hear both of us, and we've got things up and running. Before we get formally started, I'd like to give those of you who are new to us a quick overview of the structure of the webinar so that you know what to expect. The webinars are intended to be educational and informational in nature. Our goal is to focus on issues and technologies that are affecting the landscape of the entertainment lighting industry. We work closely with industry experts and leading manufacturers to develop programs and content designed to answer some of the key questions facing all of us. The webinar itself is scheduled to run about an hour. The first 40 to 45 minutes of this LED 101 webinar will focus on giving you a better understanding of the technology itself, the advancements going on within the LED market, and examples of the type of LED fixtures that are available. Use Color Kinetics products for our examples, along with some actual LED applications to give you a better idea of how these technologies can be utilized. During the session, we'll also be polling the audience to give you feedback on a variety of topics regarding LED. To give you an example, what we'll do is we'll just do a brief poll here now to get a better idea of the makeup of the audience. If you'll just give us your input, basically what we're looking to find out is how you categorize your organization. Are you in education, church or house of worship, theater and the performing arts, production company, rental house, or other kind of lighting dealer, or you deal primarily in permanent installations. So if you take a couple of minutes to fill that out for us, we'll give everybody some feedback. We have everybody's input. And again, for those of you who haven't joined us in the past, previous sessions included Richard Cadena talking about the state of the industry and building your career in entertainment lighting. We've also had one with high-end Embarco Systems regarding converging technologies, and both of those are available on the Creative Stage Lighting website as podcasts. So if anybody hasn't had an opportunity to see them and is interested, they are available. Okay, looks like pretty much everybody has voted on this. Basically, the answers that you gave to us, how would you categorize your organization? 17% of you say you're in education, 12% say you're in church or house of worship, 21% in theater or the performing arts, 40% in production companies, rental houses, lighting dealers, and 12% as permanent installers. So, thank you for your input. And we'll have some others of those as we go along. At this point, what I'd like to do is give you some background on our presenter today. John Melillo is from Philips Color Kinetics Lighting. Many of you have known the company previously as Color Kinetics. They are the leader in the development of new LED technology and an innovator in the field. John's been with Color Kinetics for over 6 years and has helped the company to introduce a variety of new products in the market, including the recent introduction of the Color Reach fixture with an output of over 5,000 lumens and light projection of over 500. John regularly conducts educational forums for Color Kinetics and has provided informational classes throughout the Northeast. Some of the projects John has worked on include the Boston Garden, Shrek the Musical, the Marriott Customs House Tower in Boston, and the historical Old North Church. Please join me in welcoming John Melillo. John, take it away.
Thanks, Kevin. I apologize right up front. I'm having a slight problem with my computer here. I'm just getting restarted right now, so I kind of memorized the slides for the most part, but I'm going to ask you just to be patient while I kind of go through my computer and as I get back logged in with you folks. But thanks so much, Kevin. The first slide that's being shown there is, I believe, of the London Eye. It's an application we did with some of our LED color test fixtures that allow the entire Ferris wheel, the largest Ferris wheel in the world, to change colors with a touch of a button. Previously, they were using a fluorescent light source and changing out lamps on a very regular basis. But they decided they wanted to do something a little bit more dynamic, and the best way to do that would be with LED technology. It's very exciting. I mean, this is one of numerous applications that are using LED technology today. It's something in which you'll see a lot more and more opportunities to use LEDs. The next slide would be of the Custom House Tower, which is in Boston, Massachusetts. It's showing the fact that we now can use LED lighting using for white light applications. It's an energy savings as well as a maintenance savings. Previous to using LED system, they were using a halogen source, which had to change out lamps every few thousand hours. And once they had a chance to make the change to using LED, it saved them 67% of their electricity costs, and it saved them on all the maintenance as well. So very, very, very exciting times here in the LED world. Kevin, the next slide would be the history of LED.
Yep.
Yeah. So the LED itself was founded. The visible LED was founded back in 1962 with a gentleman named Honyak. He was a professor up at Syracuse and worked for GE in the plastics department, and he decided that he was looking into different types of ways to use LEDs and see if he could actually get any kind of visible light out of it. And under a microscope, he saw this little hue when he actually gave power to this semiconductor device, which was called an LED at the time. He didn't think for anything of it, really. General Electric, for the most part, shelved the idea of actually doing any kind of R&D on there. And then a gentleman named Monsanto at Hewlett-Packard, the computer company, the mainframe computer company, was thinking that he would actually do look into it more because they wanted to use LEDs as indicator lights. They knew that LEDs lasted a long time, and they knew that it actually gave a slight light, but they wanted to use it on an everyday basis. So they started using LEDs only as indicator lights to let people know whether or not mechanisms or computers were either on or off. That was the only reason why. Even today, you still see LEDs being used in your computer monitors, your televisions, DVD players. Wherever you see a little green hue or a red hue of light, they're using LEDs. Just think to yourself, when was the last time you actually saw one of those lights go out on any of those items? So it was very, very exciting at the time to be able to use it on a daily basis. The LEDs kind of more in the 70s, where you started seeing them being used in calculator watches. That was the biggest thing. Whenever you press the side of your calculator watch, you would have a slight green hue, and it would allow you to see the digital display on the watch itself. So we primarily only had red color LEDs, and then we went to green LEDs. And not until the early 90s did we see any kind of blue hue of light. So we're going to talk a little bit more about the dynamics of an LED, but we've had blue LEDs that allow us to do color mixing. So we had red, green, blue LEDs for color mixing, and allowed us to get any color of the spectrum. And that's actually one of the basis of the founding of my company, Kinetics. The founders of my company decided if we can adjust the intensity using a digital processor, allowing us to change the intensity of red, green, or blue LEDs, then it'll allow us to get any color of the spectrum. and that's the basis of color kinetics. It's just regular color mixing that most theatrical folks use today. The next slide, Kevin?
Sure.
Thank you. I'm still getting on here, by the way. I apologize.
Not a problem. We got a little bit of background here in terms of the semiconductor.
Sure. Oh, so the semiconductor industry, it's the LED itself is just like the computer chips you have in your computer. They actually are made a similar way, except instead of having processing speed, these allow you to have an intensity of light coming out of it. So just like your computer is getting faster and faster and cheaper, the exact same principles happen in regards to the light getting brighter and brighter and cheaper and cheaper. So when we used to make a fixture that you'll see called a Colorblast, and you've probably seen them in the last 10 years or so, actually I have it. I'm on here right now, Kevin, so I'm all set.
Okay, cool.
You might have to drive, though, just in case.
Yep, no
so
problem.
when we actually had our Colorblast fixture, it was a third of the intensity as it is today, and it cost twice as much money, just to give you an idea. So again, the first computers that came out for the Macintosh computers back in the mid-'80s, they cost approximately $3,000, and they were 300 times slower than they are today. So the advances are the exact same thing in the LED world. All LEDs, though, they're not made of any kind of glass or brass or any kind of gases at all. There's nothing harmful with LEDs. They are made in clean room environments, but you don't have any kind of harmful materials like you do with fluorescent types of lamps that are out there. One of the great resources that I look at a lot for LED technology is if you go onto Wikipedia and you go on under, you do a search for LED, you'll get a lot of excellent information. It'll give you 10, 15 pages about the properties of LEDs and where they have come and where they're going in the future. The next slide, Kevin.
Sure.
Thank you.
Okay, so anatomy of an LED.
Sure. So this is this slide here is just showing, the left-hand picture is showing what we call a 5-millimeter LED. This is a very, very basic LED from 30, 40 years ago. They're not really used that much anymore. You will see those LEDs being used pretty much only in as indicator lights or even in traffic lights. So pretty much every traffic light you see today on the road is using 5-millimeter LEDs, and that's why you see an array of green or an array of yellow or an array of red. That's what they're using, a 5-millimeter. But it's showing, you have the LED itself is very, very small. It's about the size of a pen point, very small. It has a small little reflector cup in there that actually kind of points the light in a forward direction. And then there's like an epoxy lens just to kind of protect the whole device. And then we have two leads on the bottom. We have an anode lead and a cathode lead, just allowing power to come in and out. When we give it energy, it excites the LED, and it flickers at a very, very high rate. Now, LEDs themselves, they do actually have to dissipate heat from the device, or they won't last very long. And we're going to talk a little bit about that in a few minutes. But that's one of the reasons why this particular type of LED, a 5-millimeter LED, has gone away, is because you couldn't give it, if you gave it too much energy to get a brighter light coming out of it, it would die much quicker death. So what happens is they moved over to what we call a surface mount or a high flux LED on the right-hand side. And the LED itself is that yellow device there in the center. But all of that around it, that black and that silver, is all metal. It's all metal in order to dissipate the heat from the actual LED itself. So any kind of high brightness fixture you see, like a theatrical fixture that's throwing light a far distance, is using an LED such as this one here on the right-hand side. Next slide, Kevin. Thank you. Here's just a very brief overview of the different types of light sources that are out today. The incandescent bulb, I don't want to get too in-depth with that, but it's just your typical household light. It's very inefficient, but very inexpensive. So the LED, the lamp itself costs 25 cents for the most part, but it only has about 8 to 10 lumens per watt coming out of that particular light source. A halogen source you kind of see in many applications like as retail as well as hospitality. A very nice warm light, not very efficient, very hot, don't last very long. The fluorescent source today, either a linear fluorescent you see in commercial applications or the compact fluorescents you see in the retrofit applications that you see in Home Depot now. Everyone's talking about using fluorescent, compact fluorescent retrofits, and even in my house, I use some of those lamps today. Very efficient source, not terribly expensive, but they do have limitations. Very difficult to dim, if at all, and obviously you have some of those poisonous substances like mercury that are included in those. So we're going to talk a little bit more about fluorescent, and then you have gas discharge, such as neon, a cold cathode, two types of gas discharge lamps. And then we're going to talk about LEDs and some of the benefits of it. Kevin, you mind pressing this, the return button?
Sure, there we go.
Yeah. So the benefits of LEDs is a very, very long source life. We're talking upwards of 50, 60,000 hours of lifetime. And the LED itself doesn't blow out like a typical bulb you have in your house or in your commercial application. It actually just diminishes over time. So even though it lasts for 50, 60,000 hours, it doesn't go out. It just diminishes slowly. So the lifetime statement is saying, in fact, it's 50,000 hours to 70% initial output. So it's a little bit different than when you have a traditional light source where this blows out. These just diminish over time. So you're never going to have, say you had a line of Cove fixtures that are 100 feet long, you're never going to have one or two fixtures that are out or different color temperatures. You're going to always kind of just be at the same level, diminishing at the same rate. Very low power consumption. On the color-changing stuff in particular, LEDs, they give off about 40 lumens per watt, in particular in a saturated color. So when you think of colored applications, normally if you want to get color with a traditional light source, you put a gel or a filter over that traditional light source, and you're cutting out 30, 40, or 50% of the light. So with LEDs, because the actual light itself coming out of that chip is that certain color, you're not subtracting the light or taking a lot of the light out by putting a gel or a filter over it. And we actually call, when you think of colored applications with traditional light sources, it's called subtractive technology, where you're subtracting light to get a color. With LEDs, we call it additive color mixing. So if we use more green and more red, we're going to get a yellow. And if we add in blue, so if we have blue, red, and green all on full power, we actually get white out of that. So it allows you to be much more efficient in regards to power consumption. I'm going to show you a couple slides later on in regards to the energy savings of some applications that are using traditional sources that are now using LEDs. There's very low maintenance. There's no moving parts, nothing really to break. They're not susceptible to vibration because it's a solid state device. So there's no filament to break. If I dropped an LED fixture on the ground, nothing should happen to the LED itself. Now the fixture, the glass around it may break, but the LEDs should still be working. So that's why you see it all the time on like car brake lights or truck brake lights, because they're attached and there's nothing really to break there, and you can bounce around and bump around all you want, and you won't have the filament to break. Normally, when your headlight goes out or your brake light goes out with a older light source, a traditional light source, it's not so much it burnt out because of time. It burnt out because it actually blew out because the filament broke. There's no UV radiation at all. So every other source out there does have UV. There's zero UV coming out of a UV fixture. So if you think of museum applications, or if you think of things such as fabrics, where you're worried about having the UV staining or making issues with fabrics or artifacts, not an issue at all with UV. And one of the things that you can kind of remember is when you go into a museum, normally museums are very, very poorly or dimly lit. And that main reason is because they're really concerned about having UV causing problems to those artifacts. But now, going forward, as we use LEDs more and more, the museums themselves should be really brightening up because they're not going to be worried about the LED, the UV. Now, there's also another advantage too. There's a cool beam of light. So all the other light sources actually have a hot beam of light coming out of them. So if you stand under a fluorescent or an incandescent PAR light, usually you're feeling heat underneath that particular source. You do not feel any heat at all from the beam of light. Now there is heat, but the heat goes in the back of the fixture or the back of where the light source is. So you may see fixtures that have like some metal around it, things like that. That's really there in order to dissipate heat from the LED. So it's a great selling point in regards to theater performers. Wherever you have people that are under stage lights, they're baking under traditional sources. But going forward, you're going to see a lot more theaters using LEDs because they're not worrying about heat on the performers themselves. I'm sorry?
No, I was just going to say, no, I was trying to get in there on a pause. We just had a question here from one of the users would like to know what makes the red red and the blue blue. Is it the materials used or? Yeah,
it's the materials used. It's the different substrates that are actually used with the LEDs. And different substrates, when they're making these LEDs themselves, will allow it to be a different color. Yep. The white LED is using, it's kind of funny, it's using the different substrates to get to be a blue LED, and then they put a phosphor coating over the blue LED to get white. So in reality is whenever you see a white LED, and one of the reasons why the first white LEDs and the flashlights that you saw in Home Depot, or when the first ones you saw in cars, they were very, very blue because they really are blue. And one of the most difficult things for LEDs to get is that nice, warm, white light. It's been very difficult. Now, the LED manufacturers, the people that actually make the chips themselves, companies like LumaLEDs, which is owned by Philips, Cree out of North Carolina, Osram, Slovenia, they're getting much, much better warm whites. So you're starting to get that halogen or incandescent look, which is very, very exciting. Go ahead.
We had another question regarding life of LEDs, and I know there's variables in there, but are there any general rules that you follow?
So, I mean, this bring that up. One of the things years ago, even when Color Kinetics first came out, we were always using specs on the LEDs from the LED manufacturers. Again, the LumaLEDs, the Crees, the Philips, the Nichias. They gave us specs and said, you know what? Our LEDs will last 100,000 hours. And they really will last 100,000 hours, but it really depends on what you're doing with that LED. So anyone can buy an LED. Anyone can give it power and put it on a board. The question is, how well do you actually control the thermals that are around the diode itself? If there's too much heat around the LED, the worst thing for an LED is actually heat, and it won't last as long. Okay? Now, the other thing is, all those specs for the 100,000 hours was all used. They were just assuming that people were using them as indicator lights. Like I said before, in your TV, in your computer monitor, you would look at that just to see whether or not something's on or off. So it didn't matter if it's 70% the intensity, 50% of the intensity, 30% of the intensity. As long as you saw that it was on, you realized that the device was on. But when it comes to lighting, because you're using it actually for useful light, you actually have to have a standard that says, okay, when is this light not useful anymore? Is it 80%, 70%? It was pretty arbitrary. So we use 70% on our standards, and actually the standards coming out in the next few months, in the next year or so, are going to be using a 70% standard. Now, fluorescent sources, they do also have they have depreciation too, like 25% over the life of their lamps. So it's not uncommon, but so the lifetime really is 50,000 hours or so, and that's usually in the worst case scenarios, such as very, very high ambient temperatures. Or, but if things are being used in more traditional areas, say indoor applications or in cooler environments, it's going to last longer than that. So if I had an exterior application in Minnesota, and I had the exact same application but it was in Las Vegas, they're both going to work. They're both going to work for a long time. But I can assure you, the Minnesota application is going to last probably 10, 15, 20,000 hours longer than the Las Vegas one. So it will still work, still function, just won't last as long. That's the lifetime issue.
Gotcha. Okay. Now, another question here in terms of consistency of colors in LEDs. One of the things I can tell you from our experience, particularly with Color Kinetics, is they have some technologies that allow them to be extremely consistent in their colors, to the point where we've used their fixtures in our rental inventory, had fixtures that we brought in over a year ago, added additional ones recently, and the color consistency when we take them out and do a show and look to dial in a very specific color, they're just dead on. So there's a lot of improvements that have been made there, and Color Kinetics specifically has some technologies that really address that as well.
Yeah, absolutely. And what happens is, when LEDs are actually made, none of them actually match completely. So they have a thing called the binning process. Well, they'll put certain colors in reds and certain colors of greens and certain colors of blues all in different bins. And depending on how well you match those bins will give you consistency from fixture to fixture. But what happens is when you have companies that are out there that use that don't sell very many fixtures, or they're new to the industry, they might not have consistency from fixture to fixture from 5 months from now, from a year from now. When you start working with companies that do this on a regular basis all the time, they can make it so they buy certain things and can place the LEDs themselves on the fixtures to allow consistency, fixture to fixture, build over build, year over year. And it's very important to think about that. In particular, color is one thing. Color isn't, your eye isn't as, you can't perceive things as much with color as you can with white. When you have a variation of white on a wall, on a white wall, a white lamp, a light source, and a white wall, your eye can pick up those variances much quicker than they can with color. So.
Okay, great. Okay,
now,
move on to the next.
Yeah, well, just one more thing. The LEDs themselves, because they are semiconductors, it's very easy to actually digitally control these things. So most of the light sources, what we call analog, LEDs are digital. So it allows you to do much more creative things, changing colors, put in processor on there, put computers on there. That's very, very different with an LED source, more so than a conventional source. And they're very fast response. So LEDs themselves, they flicker at a very high rate, which allows you to get more intensity. The faster they flicker, the brighter it is. So when people turn them on and off, thinking of like turning on and off the light switch, it doesn't matter. You can turn it on and off all day long because it's flickering at a high rate anyway. Next slide, Kevin.
Yep, just a quick one off this one. Somebody had asked what was SSL stand for. It's basically solid state lighting. It's representative of the category.
Yeah.
Okay, and we do have other questions, and just knowing what this presentation is like, I know we're going to get to some of those as we go along, so if it seems like we might be overlooking yours, don't assume that. We're going to be getting to a lot of these things, as particularly there's a lot of questions about white fixtures and the use of white. We'll be getting to that a little bit later. Okay, go ahead, John.
Sure. Just a little background. I don't want to spend too much time on this slide here talking about where LEDs have been used. I mentioned before, like calculator watches. They've been used in PDAs and some of the earlier cell phones. A lot of the cell phones now use LCD screens. LEDs were used when you actually pressed the button on the side, when you had the dark digital display, and it would turn on and actually illuminate that particular screen. LED exit signs been used now for years. Pretty much every exit sign that's actually built today that's installed is LED based, mainly because it's on 24 hours a day and because it's red. We've talked about how almost all new cars, their brake lights now use LEDs. Some even the headlights use LEDs. A lot of the signage companies for channel letters are using LEDs as well. Even other companies, GE does a nice job with making signage LEDs. Color Kinetics is more of color changing, so sometimes it's a little bit overkill when you do color changing stuff. But when it comes to just like a straight red for an S that you see in this picture here, they make just red strips of LEDs to allow you to get that color. Every scoreboard you see today that's put in, as well as almost every one of them that's in Times Square, is using an LED-based screen. So the prices have come down dramatically. Similar scoreboards that were put in, 10 years ago, are a quarter of the cost or half the cost of what they were then. So the future really is general illumination, and we're going to see some nice applications in a short period of time here. But right now, we really can't compete fully with fluorescent. There are certain applications LEDs do a great job with. Other applications like your traditional light sources that you have in your offices or your troughs, fluorescents do an excellent job for an inexpensive cost. So we're looking to get there. We will get there. It's just not there just yet for just general straight illumination.
I have a question here regarding LED devices and when it's felt they'll be able to replace standard wash fixtures like an ET Source 4 in regards to color temperature.
Sure.
I've got some thoughts on that, but why don't we hear what you have to say, John?
No, absolutely. So the intensities are very close to being there. We've been in developing a LICO fixture for a couple of years now. We have the engine to make the intensity bright enough. The real problem we have is with the optics to get yourself a very, very a nice beam shape coming out of the fixture, because it's a multiple point source, right? So if you have all these LEDs in an array and you try to put it around put a lens around it, it comes out a little bit fuzzy around the edges, and we know that certain designers don't like to see that. So as far as intensity is concerned, we can get there today. The real question is how do we make it so it's optically acceptable to what you have today, okay? Because I'm going to show you a fixture in a little bit that can shine like 500 feet in the air using minimal power, color-changing LEDs, but it's not made to be a focused light, a Source 4 type of fixture just yet. Now, in regards to white light, we can get that white light. You can use red, green, blue to get white. You can add an amber in there to get yourself a better white light, or you just add white LEDs. All those things combined will allow you to get a nice white light.
Want me to move on now, John?
Yes, please. Thank you.
Okay.
Just a very, very basic chart just showing, where LEDs are heading and the different light sources in lumens per watt. Everything seems a little bit inflated here. Maybe these are mainly due to tests that are done in laboratories. But incandescence, just the most important thing is to see the trends of where incandescence is going. There's been minimal, if not no advances at all in that light source in regards to lumens per watt. It's not going anywhere soon, and what's happening, some of the lighting manufacturers, people that make lamps, are going to start not making it. The parent company of my company, Kinetics, Philips, is going to stop making the incandescent bulb in a couple of years. Well, several years. And I think there's other manufacturers saying the same thing. Fluorescent sources have been around now for 50, 60 years. Very, very, very efficient. 80, 90 lumens per watt out of these light sources. Very, very efficient and very inexpensive. And they will be around for a long time. But to give you an idea of where Philips is heading, Philips is spending $0 on research and development for fluorescent sources. All of their research and development right now is on LED technology. So they're pretty much tapped out in fluorescent. The sky's pretty much the limit in regards to LED. And you're seeing here now, out of fixtures, we're getting around 40 to 45 lumens per watt out of fixtures, okay? In laboratory tests, and you will see claims out there, laboratory tests, they have gotten 100, 150 lumens per watt. Now, kind of misleading, because what happens is when you see these claims of 150 lumens per watt, yes, they can do it. But when they do it in a environmental chamber at like negative 20 degrees Fahrenheit, and they do it for a fraction of a second, and they do a quick test to see how bright it is. But it still means the fact that it is getting brighter and brighter. The real question is, how do we actually use it in an everyday application, and how do we dissipate the heat in order to have a 60, a 70, 80 lumens per watt fixture? But it is not far away. I guarantee you it's no more than 2 or 3 years away of getting to 70, 80 lumens per watt of these fixtures. So it's rapidly increasing. Next slide.
Sure.
This chart here is just showing the cost of light. So you can't just look at the upfront costs from an incandescent source or fluorescent source. You have to put the whole thing together, right? So even though the incandescent light bulb costs 25 cents, in a commercial application, the amount of money you're going to be spending or wasting in energy, replacement costs, and labor costs to replace that stuff. So if you actually had to have a maintenance person going up there and changing out light bulbs, it's substantially more money with an incandescent source than it is for an LED source or fluorescent source. Right now, if you look at that particular chart, we're between, the LED world is between the halogen and fluorescent sources. So when you take into consideration all of those factors, it's almost a wash in regards to, between halogen and fluorescent sources. So don't just think of upfront costs, okay? Next slide.
Sure.
Just a couple of examples here of energy conservation. The annual cost savings, this is the top right-hand picture there, is the Hard Rock Casino in Las Vegas, Nevada. And you, depending on how big of a picture it is on your computer, the fixtures are all on the ground, or at least are one story up on that monorail that's going across. And every 15 feet, they have another array of fixtures. They have 5 of what we call a Colorblast, lighting up 11 stories. So, and this is 4 years ago. So it's gotten much, much brighter since then if you wanted to do the same thing. But they use what we call Martin Iridium fixtures. They were, I think, 600-watt fixtures. And I guess it was a maintenance nightmare for them, and it cost them a lot to maintain and also for energy. But they were just replacing one-for-one replacement. It saved them $41,000 a year in energy and maintenance costs. It was a 2.5-year payback to go to an LED system. And the other thing, too, is no one really took into consideration how much more in regards to effects can be done. So the entire building can be dancing, changing colors, just using the exact standard fixtures we use on an everyday basis in the LED world.
One of the things I was just going to mention, John, too, is we have been talking that these numbers really don't take into consideration when you're talking about interior applications, the cost savings in lower air conditioning bills based on heat output. When we're down south and talking to dealers and end users, one of the things in terms of churches, convention centers, things like that, when they're using traditional fixtures, there's a lot of heat output, which raises their air conditioning costs substantially. With LED, with that lower heat output, they're not experiencing that same type of cost as well. So there's an additional cost savings there for interior that's not even reflected in these numbers.
Absolutely. An example of that is what you just remember when you go into a retail application, a retail store. In particular, one comes out, and I don't want to, pigeonhole this company, but when you go into a Gap stores, at least until recently, they had incandescent power lights on tracks, 90, 100-watt lamps, hundreds of them in the store. They are running their air conditioner year-round, even in cold weather locations, because there's so much heat coming out of those lamps that they have to run the air conditioners year-round, which is just absurd when you think about it. But that's the way they wanted it to look, and that's what they're using right now. There are other sources you can use, but they're using incandescent sources. But very quickly, it's going to change to using LED sources for that, because it's a focused beam of light. It'll be a lot more energy efficient, and the costs are going to be coming down a lot. But they will not be, hopefully not be being using air conditioners in the wintertime anymore. The second one down there looks like a river or a lake. That's Boathouse Row in Philadelphia. They have a river there where they do have all the rowers, the crew boats, and they had incandescent Christmas tree lights outlining all those buildings. And it was just a maintenance disaster because they had to go out and replace all the lamps. It cost them a lot for energy, and they decided to go to a color-changing string light that we provide, and it saved them $57,000 a year annual cost. It was a 2-year payback in order to have the system functioning even better than what they had before. So the other thing too is, again, that once they had that one color on that building, that's what they had. These buildings, all 7 or 8 of them, I think there's 10 of them total. You can't see them in the picture. They're all controlled together, so they actually play shows and do like 4th of July shows over all those different buildings, which is pretty neat.
Yeah, I was actually down in Philly and saw that. At the time, didn't realize it was color kinetics, but even my wife, who's a layperson, was really impressed with it.
Yeah. Next slide, Kevin, please.
Sure.
So the trends in LED lighting, 6-7 years ago, I was selling LED systems, and it was a the end users that I spoke to on the phone never even knew what an LED was. it was remarkable. So now, just years later, I don't have to explain to people that the fundamentals of LEDs or the benefits of it. Now, we see on an everyday basis in my world, we see designers, architects specifying lighting systems, which is very good too. People were very, very apprehensive years ago about specifying things they didn't really understand, and now they're much, much more comfortable in doing that. And there's just a massive, massive growth in the LED world, massive. We hear about it all the time. You're hearing about it on the news. You're hearing about it in the papers. And the Department of Energy is even understanding this, and they're investing a lot of research and development dollars in researching LED technology.
We have a poll question that might come in applicable here. I wasn't sure where we would use this, but one of the things I was interested in finding out a little bit more about is, are you currently or do you plan to utilize LED technology in your organization? Choices are you're already utilizing it, you're planning on utilizing it within the next 6 months, within the next year, or you don't have any plans to implement LED technology. So we'll just give you a couple of seconds to respond to that. John, go ahead if you wanted to fill in the blanks on some of this.
No, absolutely. I just wanted to go back to saying the fact that we get requests. I mean, we take my company gets incoming emails 20 a day sometimes in regards to questions about technologies that are out there. So it is very exciting. It's a green technology too. So when you think about where the nation's heading in regards to energy independence, it's something that's very exciting that people like to talk to you about it because they want to do the best they can, reducing their their carbon footprint and so on and so forth. So. Okay.
All right. Well, we'll give you a couple of seconds to anybody else that wants to participate in the poll, and we'll be closing that out. Got some interesting results, which I'll post here for you. Okay. It looks like. All right. So basically, 52% of you say you're already utilizing LED, which is a good, encouraging trend. 12% say you're considering within the next 6 months, 20% within the next year, and 16% of you say presently you don't have any plans to implement LED technology. But I think it's an indication of the growing trend and people moving in that direction. The fact that better than 50% of the audience is already utilizing and adopting LED. Okay, go ahead, John.
The next slide. I still see the poll results here.
Oh, okay. There, they should be gone now.
Here we go. Okay. So LED standards, again, it's very, very important. I mean, there's a lot of companies out there today that are coming out with their first fixtures, and they want to kind of get involved in the LED world, which is great. Everyone's being very, very positive about it. But the problem is there's minimal standards right now regarding talking about, lifetime, any kind of third-party independent testing, things like that. But make sure whenever, no matter what type of LED fixture that you use, make sure that you do your homework, find out a lot about the company, what they've done in the past, and find out if all of their testing is done via a third-party independent lab. And most importantly, in particular for permanent install work, you're really going to make sure the entire system is UL listed. I know it sounds very, very basic, but there's a lot of companies out there that don't always have UL approval. So just keep all those things in mind when you're thinking about LEDs and using them in the future, and you'll be a lot happier, I believe. The next slide.
Sure. Some of the standards involved?
Yes, there's many, many different organizations, NEMA, IES, obviously you have the Lighting Research Center, which is very exciting. They have a whole department, I wouldn't call it department, a whole area for the Lighting Research Center, which is based in Troy, New York, not too far from Creative Stage, where they're just doing all independent testing on LEDs and where the trends are heading. But there's a lot of Energy Star is getting involved. UL is involved as well. Everyone wants to kind of come together and have this be as successful as we possibly can make it. And until we have standards, and all these companies are working on it. It's going to be a little bit of a tough time, but it's all happening in the very near future. If it isn't now, it'll be in the next 6 months to a year.
And we've also got a little bit more about Energy Star.
Sure. Here we go. Hang on. So Energy Star, some of the first LED fixtures will be stamped Energy Star in the next few months. The end of September, there was some kind of board that met, and finally it allowed LED fixtures to be approved by Energy Star. Now, it's not necessarily a one-for-one replacement. They do it more on application basis. So, in particular, like we provide an under-cabinet light, okay, in the architectural wall for your house or for task lighting. It's very, very a nice fixture. But they're saying, okay, we can use LEDs, and if they meet these certain lumens per watt of these LEDs, we'll stamp an Energy Star stamp on it. But there's still a little bit more work to do with that. But in the next few months, year or so, you're going to start hearing more and more about LED fixtures actually having an Energy Star label on it. Next slide.
Sure. Okay, so now we get into some of the application studies, and I think this is where it really gets interesting because it gives everybody a better sense of how LED technology is already being utilized out there. And I think that's really it's great to understand the technology. It's another thing to see how it's being applied. And John's put together some tremendous examples for us of different types of fixtures and different types of applications. So it'll really give you an idea of, how this technology is utilized.
Yeah, absolutely. So just in regards to LED systems, in particular the controllable color applications, you really have to make sure you're very, you really understand that it's not just a fixture, it's also how are the fixtures being driven, either by a line voltage device or a low voltage device, and the controllers that are involved. You really got to make sure you have all those things under control before you kind of come to a full understanding of where these fixtures are heading. Some of the things that are out there today, they might be excellent fixtures, but they might need to have a DMX console to run them, and that doesn't do very much in regards to ease of installation for permanent installs. Some of the things that we offer are very user-friendly. You can use your little laptop, or just to create very, very basic effects with the easy user interface. But you have to really kind of understand what you're getting yourself into. It's not hard stuff, but sometimes you have to make sure that you can have the control to run the lights properly. Next slide.
Sure.
So just to give you a little background about Color Kinetics, we are a U.S.-based company. We're based in Burlington, Massachusetts. We were founded about 10 years ago, just over 10 years ago, in downtown Boston. But we take LED lighting very seriously. That's all we actually do is just LED lighting. It's the only fixtures we've ever made. And many of the other companies out there that do color-changing LED products, a lot of them are using the technology that we created over the course of our existence. We have over 250 patents under our patent portfolio, and I think probably double that in application status right now. But we also have 50 electrical engineers in our office in Burlington, and 150 other employees there as well. We do everything. All R&D work is done in Burlington, Massachusetts. We do make our fixtures overseas. We make many of them in Asia, and then we make some of the most popular ones, the Colorblast and the Color Reach, are made in Mexico. But we used to manufacture in the U.S., and unfortunately it was just very, very expensive for us, and like you would imagine, and we had to look elsewhere, or we would have been in some trouble, I think, competitively. So, but we do have 20 people that work for Color Kinetics, 20 people that work for our company that are on the ground in Mexico, in China, working directly with these very, very high volume, high producing contract manufacturers. We only work with the Class A fabricators, the fabricators that actually make all the PDAs and cell phones that you use. So these are not just run-of-the-mill types of contract manufacturers. The next slide.
Sure. Okay, so we're talking about the color blazes. These are some of the units, the Color Blazes and Color Blasts, some of the ones that we've had the most experience with because we use them extensively in our rental group. Also, these have tended to be the ones that our dealers have been the most heavily involved with, utilizing them in a matter of fact, this past weekend I was just up in Lake Placid, and we're doing Stars on Ice right now, the national tour. And there were probably a couple of hundred Color Kinetic Color Blast 12s on that tour going all around the country.
Absolutely. And then this fixture, the next fixture we're going to show you, are both very, very heavily used in the production world, the rental world. This fixture here is called a Color Blaze. It comes in a 4-foot section as well as a 6-foot section. It's very, very bright. It's made to be more like a cyc light or a border light. It only draws, a few hundred watts per fixture. Each one of the 6-inch segments of the fixture itself. So on the 4-foot piece, there's 8 individual addresses. So you can do chases in each one of those fixtures. But very, very popular. There's no, when you think of existing applications where border lights are being used and they have to be used on a dimming system, no dimming systems needed at all. This plugs directly into 120. And then you have your DMX or your Color Kinetics controller going directly in with an XLR connector. So pretty close to being industry standard for when it comes to border lights that are out there in the rental market. There are other companies that do it as well. We think we do it we think we do it the best and the cheapest. So that's one of the reasons why we've been so successful with it.
John, I got a couple of questions here.
Yep.
They're asking what watt LED does the Color Blaze use?
Sure.
And then
so
also,
yeah, go ahead.
No, I was going to say, and then also, what are the throw distances for the Color Blaze fixture?
Sure. So the wattage of the LEDs we use in the Color Blaze are 1 watt LEDs. They are what we call Cree 7090 1 watt LEDs. So there's 18 LEDs in each one of those 6 inches or 6-inch arrays. And I have a calculator here. I'll do some 18 times 12. 216 1 watt LEDs in a 6-foot section. So you're getting a ton of light. You can throw light 30, 40 feet, no problem. You can even throw it much further than that if it's a really dark application. But to evenly wash maybe a cyc 30 feet from the floor up, 6 inches off, very, very easy to do. We do it on a regular basis. And just the two sizes, the 6-foot and the 4-foot, is just a matter of what you can fit where.
Okay. Next one.
Next slide is Colorblast. Colorblast TR. This is one of our flagship products we came out with 7, 8 years ago. We've had a few different variations of it. The most recent one we came out with is a Colorblast 12 TR. And this is just mainly used for the touring market or the production market where people are actually moving these fixtures around. They are low voltage devices and people just run their XLR, their DMX cables around and place these fixtures all over the place. They've been used as truss warmers, lights up columns, works in exhibits, many, many, many different places for this stuff to go. When you go to a wedding and that wedding happens to have some colored lights, a lot of times they used to use just par lights with gels over them. Now when you go to weddings, they're color-changing weddings. So it's pretty neat to see. Just when you as a layperson that you go out to a wedding and you just go look and you say, oh, why is this this venue's color-changing? It's using fixtures just like this, the Colorblast 12 TR. Next picture.
Sure. And just from a rental standpoint, I can tell you that we see a tremendous amount of venues that are utilizing these in corporate events, as John was saying, in weddings and other tent kind of events. And one of the things they love is the ability to dial in color through the power supply on the TR units. But if they want to dial into a very specific color, for instance, they're working with a corporation and they want to dial into that very specific IBM blue or that very specific Cancer Society pink, they're able to do that by running it through the console. So, they're able to do that very well, get a real consistent color spread across the entire event, and we've had tremendous results with them.
No, absolutely. There's too many possibilities to use those fixtures. Whenever you watch items, the things on TV, or you watch like rock shows on TV, or you watch award shows, the color blasts are everywhere. You'll see them everywhere. In this particular application, this is a Nintendo booth at the E3 convention. They use like hundreds of them up in the ceiling, and they're not only to be laying on the floor, but also to look at directly, so you can actually see the colors coming out of it. But this is just one example of using this particular fixture in a convention hall. Next slide.
Sure. Now we're talking the TRs.
So we're going to talk a little bit more about white light applications in a bit, but I wanted to kind of put this with the production world. This is what we call an IWTR, a very, very nice white light color temperature control. So you can actually adjust the color temperature from 2700 Kelvin to 5500 Kelvin and get a very, very nice white light. It's excellent in small TV environments where you want to dial in a specific color temperature. It's being used a lot in small video conferencing areas, above podiums where you have presenters that are underneath and they don't want to have them baking under that heat and be able to adjust the color temperature. But it's the fixture's been out now for like six or 8 months now, and we've had a lot of success in the small TV market. But it's been very exciting. The next picture is going to show you an application where we used the fixtures to do a cooking show. So this cooking show at it's called Rustic Kitchen. They have the color the IW Blast up in the ceiling there. They have a high definition camera back there, and back in the back of the room, and they have the on-air talent that's underneath it. But it works very, very well in smaller studios, such as what you see here.
Yeah, we've that's one of the areas that we've heard the strongest interest in these. Where we're seeing a need are in things like churches where they're doing video applications, filming the actual service. We've seen it in corporate event market where they're either looking to film the event or they're looking to put a white light and be able to dial in the color temperature on a presenter, but they're concerned about the heat output so they're not frying the presenter up on the podium. So we're seeing a lot. I'm sorry, went too far ahead, John. We're seeing a lot of interest in this fixture, and I think that this is really well suited to that whole video application and also theater kind of environment.
Absolutely. Those fixtures, all the Colorblast fixtures, they only draw 50 watts when all the LEDs are on full intensity. So whenever you have a color changing or you're doing a different color temperature, it's even drawing less than that to give you an idea of consumption. So all those housings, all those metal housings are all made to dissipate 50 watts worth of heat. And 50 watts of heat away from the LEDs makes the fixtures last 50 or 60,000 hours. Very important to dissipate the heat from the LEDs themselves. This fixture here is called the Colorblast 12 Power Core. Again, these all look similar, but they're for different items. The Colorblast 12 TR was a low voltage device where you had to have a low voltage power supply and bring back all the cables and home-mounted cables back to the power supply. The Colorblast 12 Power Core is very exciting because it actually runs line voltage to the fixture. And in the same cable, the fourth wire, if you run 4-gauge wire, 4-conductor wire to the fixture itself, it has the control signal as well. There's no separate wire for control, which is awesome when it comes to permanent installation. So if you had an installation on the side of a building, you can go to the next slide, Kevin.
Sure.
If you have an installation on the side of the building, a contractor would just run 4-conductor wire all the way down the building, and he'd mount these fixtures directly to a junction box. And he'd have both his power and his control all in one wire. There are other companies and even things that we did way back when that you'd have to have 120 volts to the fixture, but then a separate communication wire, either a Cat5 cable or a DMX cable. So the fact for permanent installs that a contractor can run this regular wire, stuff he deals with on a day-to-day basis, it's very, very, very easy. Very easy to use. An application here, this is a newer shopping area that put a bunch of our Colorblast the power cores in the side of the building. You can see what it did to that particular location. It looks very, very nice. And it gives you an idea of the throw, too. These fixtures throw 20, 30, 40 feet. It really depends on how they're mounted and what kind of ambient light. Now, some of the things look a little bit washed out. And that brown building in the back, more similar ones. When you have a lot of ambient light, a lot of white light, or these high-pressure sodiums, it washes out color. So it's really important when you want to color your building on the outside, or you got to make sure that you have to keep those things in mind of what you have that's in the area that may hurt the application for you for color. But it has nothing to do with LEDs. This has to do with color lighting.
John, I had a question here. I didn't want us to get too far ahead of it. It was a question regarding dimming, and how do any of these fixtures work through a traditional dimmer rack? I thought that would be something we'd go ahead and get addressed right now.
Everything you've seen so far, we're going to show you some stuff, a couple of fixtures later on that actually work with dimming racks. These all dim via control. So when I say control, there's usually either a color kinetics controller or a DMX controller. They dim by actually controlling the intensity of the red, green, and blue, but you wouldn't put it on a dimming rack. You always have to feed it 120, and it really depends on how much juice that fixture is pulling, but there's no real dimming rack per se that you use to have these fixtures run. You always have to give it a constant 120 feed from the work, and you control the intensity by bringing down the red, the green, or the blue intensity to bring it dimmer. I hope that makes sense.
Yeah,
but it's all via control.
Okay, I think that does. And I think we're at the color reach here.
Yeah, the color reach. This is a very, very exciting fixture. Brand new. We just showed it at LDI recently. It's a very large fixture. It probably is about 25 inches by 25 inches, the face of it. It weighs about 75 pounds. But it's an exterior floodlight that can throw light 400 or 500 feet with very little difficulty. Very bright. It only draws on full white. So when all the LEDs, red, green, and blue LEDs are on, it only draws 290 watts. And to give you an idea, I'm going to show you this next picture here. This is a demonstration we were doing in Los Angeles where we were showing there was one fixture on the bottom shining across, diagonally across that building. That building's 21 stories tall. So that's using one fixture on blue. So if it's just on blue, it's only drawing about 100 watts to get that much output on the building, which is just remarkable. People don't believe me. If you actually had it on white, if you had the red, green, and blue, it'd be brighter. It'd be on white, but it'd only be drawing 290 watts. So very, very exciting fixture. If you want to wash the outside of buildings, 5, 6, 10 stories, we make these different lenses that allow you to have more of a wash as opposed to a stripe of light. It's color changing. You can change the color with the standard controllers or a DMX controller. So this is going to be a revolutionary fixture. We have just made our first batch recently, and we're selling it now, but it's a very, very exciting fixture, and we've gotten a lot of unbelievable feedback.
Yeah, and I think, it's also at an attractive, price point. I mean, it's very competitive in the market. We've gotten a lot of really good response from people that we've talked about it with, and they really like it from an application standpoint.
Yeah, I mean, just think of all the things in the exterior of a building, right? You don't want to go out and change light bulbs, and you want color. When you want to put color on a building like that, you have to have a 1,000-watt metal halide and put a gel or a filter over it. So you're going to be using, 3 or 4 times the amount of energy to get that lit up there, and then you have to go out and change the gel or filter, and you probably wouldn't even get it as high on the building anyway. So all those things combined, you have to take those things into consideration, the fact that you're using an LED source.
Exactly. Yeah, I mean, it's amazing because we've been talking about some major applications that, are landmarks around the country that are looking at this to do exterior lighting, and as we talk to them and we talk about pricing and those type of things, they've been really impressed. They just, everybody that we're saying, talking with, really didn't believe that LED had this kind of throw capability. So that's a major factor right there.
Absolutely, it's very exciting.
Got a couple of questions here in terms of what's the beam angle on the color reach, and a question about different lenses. So I thought combine the two of those together.
Absolutely. Thank you for bringing that up. So the beam angle that comes out of the fixture itself, the bare fixture, comes with a 5-degree beam that will allow you to go those very, very high heights. Now, we have different lens options. I want to say that I don't know exactly off the top of my head. They are on the website. 8 degree, 13 degree, 21 degree, 30, 40, and 60 degree lenses, I think, that'll allow you to really spread that light out. Now, just keep in mind that, it's a lot easier to go from a really tight beam to a wide beam than it is to go from a wide beam to a tight beam. So we'd rather start with a very, very narrow beam, and if we use these very, very efficient holographic lenses, it allows us to have a nice wash of light. And if you want to talk to your district managers that you deal with on a regular basis, I can send them. I have more pictures. I didn't put them on the demonstration of other applications. Be happy to send them to you guys.
Great. Okay.
Next slide.
Yep.
This is new color grays. This is pretty much, if you've seen the color blaze, this is an exterior version of it at about half the intensity. So it's a linear fixture about 3 inches by 3 inches in diameter, and it comes in 4 sections, 3-foot and 2-foot sections. Every 1 foot of it is actually controllable. So if you were going to put the fixture on a ledge, it can go up and actually graze the surface. It's a very, very narrow 10-degree beam, so if you put it right against your surface, it'll shine up, 20, 30 feet if you wanted it to. But I kind of call it like the exterior version of a color blaze, so I kind of call it like a baby blaze. But it's a new fixture now for a few months now. The next picture, show you a photo of an installation. This is the downstream casino in Oklahoma, where it's about a 12-story building. Every single story had a row of the color grays, and you can see the effectiveness of it. It gives you nice, even wash across. You don't have any scalloping effects. Very, very nice. It does show textures pretty well. You can't really see it in the picture. But all 4 sides of this building are using the color grays, and they make the whole building change colors and dance and so on and so forth. But very, very exciting fixture for us. Very exciting.
Okay. Sorry if I'm not keeping up with you, John. This is a very active crowd. We are getting more questions coming through here, and I'm trying to respond to as many of them as I can. Typing, because we're just going to run out of time. So if I lag a little bit sometimes in switching the slides, I apologize. I'm just trying to keep up with everybody's questions. I'm sorry. Go ahead.
That's okay. We're showing here the iColor Cove series. We make a few different versions of them. This is 2 of the 3 versions. Every 1-foot section is controllable. It's made to light up coves or soffits in buildings and hospitality locations. This is our bread and butter. We've sold hundreds of thousands of feet of this throughout the world. A lot of it, as you would imagine, happens in casinos because they want color. They want color changing. If you can go to the next picture here,
sure.
We're showing. I'm trying to think of this particular. We're showing the middle picture and the right picture, the iColor Cove, in different types of applications. There's a cove around the center round circle there, and then in each one of these green light boxes has Cove in there as well. The next picture might be a little bit easier.
Sure.
Thank you. This left-hand application, it's color changing. There's 2 coves there. There's also the iColor Cove and the circulation desk. And then on the right-hand side, you see this hotel ballroom. It's changing colors. Obviously, everything is controllable. So if you have a hotel ballroom and you want to be able to sell to your customer or your bride a specific color, it's a matter of pressing a button. The color of the room is going to be a certain color, and then it's going to match that bride's dress. I mean, it's pretty remarkable stuff. We've seen a lot of installations in particular. In the Northeast, I've seen a lot in New York as well as in New Jersey, where a lot of these banquet facilities are adding color changing to the actual ballroom, charging a fee, an upcharge, $400 or $500, just by pressing a button to have it match exactly the same color as their wedding party. The left.
John, what are the different lengths on the coves? They come in what inch?
They all come in 1 inch. They all come in 1 inch sections. We do make smaller ones, pretty much 6 inch sections, but 1 foot sections, excuse me, are usually all that is needed. It's very rare we sell too many 6 inch sections. The 1 foot sections even allow you to do those slight radiuses, as you can see above that circulation desk. And it allows you to connect end to end. So it's not like you don't think of it as like a fluorescent lamp where you put a 4 foot section up, you put a gel over it, things like that. These all come very easy to install, but they come in 1 foot pieces. You just click them together.
And then another question is, what kind of controls can be used? Is it all DMX? Is the and how do the drivers work?
Right. So everything is DMX compatible. The Color Kinetics controllers are very easy user interfaces. They actually spit out DMX signals, okay? But it's made primarily for our fixtures. You could run other fixtures with our Color Kinetics controllers, but it's not like an easy thing to do. They're really made to kind of use the Color Kinetics fixtures, but they do actually spit out DMX signals. You can use other types of controllers that are out there, Light Jockey, any kind of DMX console as well. Just when you think of an architectural application, in particular, both of these things here, there's really no reason to have a DMX console unless you are going to be having a production company coming in and want to control both the lights up in the top and the Cove as well as the lights on the stage. But if you're having just a regular application, you probably want to use an architectural controller that's very, very user-friendly for the staff to use, as opposed to hiring a technician to come in to run the lights.
Okay. All right. And they wanted to know what about power supplies and draw per foot.
Okay. The Cove MX, the highest output version, which is actually not being shown here for the examples, is line voltage. So they're running that fixture at 120 volt. So we usually call it data enabler. It's a little box. It kind of looks like a power supply, but it isn't. The power supply is actually included in the fixture itself. But we send, similar to the Colorblast 12 power core, we send 4 wires down to the fixtures. Same thing happens with the Cove. But you can run 60 feet of product up to 180 feet away from your little data enabler. So it allows you to go very long runs and a fair amount of fixtures at 120 volt. The Cove QLX, the smaller one, is actually a low voltage device. So for every 20 linear feet of product, you do need to home run back to a small power supply. Okay? And that power supply runs 20 linear feet. You can then daisy chain all the power supplies and data enablers to connect and to this daisy chain the data. So if you had 1,000 feet of product, you would need, I guess you need how many? 20? My math's terrible right now. You would need 50 power supplies, but you can just daisy chain all those power supplies together, and you can control the entire building. So most of the things we come out with for the color side are using the line voltage power core technology. Some of the smaller devices, the string lights, the low lights, still use low voltage transformers for it. But we're trying to get ourselves away as much as we can from the low voltage because it is so much easier for installation using the line voltage technology.
Okay.
Next question.
Sure.
Thank you.
Yeah, that's a real nice example.
Yeah, this is using the iColor Cove fixture in the AOL Time Warner building in New York. So on the top of each one of these panels, top and bottom is using the iColor Cove and lighting up those panels. And obviously it's just controlled. Each one of those fixtures is individually controlled. You can tell every 1 foot section to do something different. And it's all a matter of how you program it and address it. Next slide, Kevin.
Sure. Got the Hollywood
sorry. Yeah, this is using the iColor Cove MX power core. This is the line voltage Cove. It's showing the intensity. It's lighting up these 6-foot tall panels using the linear Cove fixtures. It is only an indoor rated fixture. They did cover this up. It is outside, but it is covered so there's no water on it. But this installation could have never have happened unless they used the line voltage. They have all the data enablers, all the devices on the bottom on both sides, and they run it all with the top. If they had to use a low voltage device, they'd have power supplies all over the place in that amphitheater. So it just gives you an idea of the intensity and how much it helps to have line voltage technology. Next slide.
Sure.
This is a Steve Slash to make a fountain fixture, an awesome fountain fixture. It's color changing. It's controllable. It's made in Very, very robust brass housing. It's IP68 rated. It can go into 15 feet of water. We do very high-profile installations with this. The next two pictures, you'll take a look. The first picture is just a standard fountain, but it came out beautiful, which they're using, a dozen or so of these sea splashes. And obviously, they can change the colors to whatever they want using a controller. One of the main problems with fountains is the fact that it's very difficult to maintain these fountains with the lights. These things last a long time. And the other thing that's cool is these things do not have to be in water year-round. So if you ever drain your fountain, most times when you drain your fountain, you have to turn your light off because the light is made to go in water, and it will blow out immediately if you don't put water around it. These fixtures can be dry. So if you have a sculpture or something you want to light even in cold weather locations, you can using the C-Splash fixture. Next picture.
Sure.
And this is one of the most impressive installations we've ever done as a company. This is the Wynn Lake in Las Vegas. So Steve Wynn, who created the Bellagio, he always was very, very upset because when they made the Bellagio, they spent $80 million on the lake in front of the Bellagio. And he felt it was a complete waste of money to allow the general public to watch the show of all those fountains going crazy in front of the lake. So when he made his own hotel a couple of years later, or several years later, he put a mountain right in front of his hotel and put a lake between the hotel and the mountain. And this lake is an acre and a half in size. Well, if there's 20,000 square feet, it's probably not an acre and a half. But it's a very, very large lake. And it has 4,000 of those C-Splash fixtures all put on a grid. So it's all on a grid 3 feet apart. Okay? So it's 3 feet apart of every one of them, and they act like pixels. And what they did was, they're only 3 feet below the water. They make the water shimmy with bubbles to give it some texture, to kind of make it seem like an ice rink almost. And then they play video through these fixtures, and it allows it to be like a video wall. It's one of the coolest things you've ever seen. If you have a chance when you go to Vegas, it's very impressive.
The thing I could say that speaks to that is I spent a lot of time with Richard Cadena from PLSN when I was out at LDI, and the only show that he insisted we go to see was this show. He said it was the coolest thing, and I mean, this is a guy that can get in to see any show in Vegas whenever he wants, and this was the one, and it's a free show, and he was, he definitely said you have to see this show.
Yeah, very, very cool. Very cool.
Yeah, and a nice example, for any of you who attended our last one, and we talked a little bit about converging technologies, this is an excellent example because it's also using a lot of barcode technology to project on that waterfall, CK equipment doing all the color changing underneath the water, moving lights all over the place. So it's a good example of the type of things that the industry is doing to bring a lot of technology together. Go ahead, John.
Sure, no, it's fine. The next slide will be fine.
Okay.
No, this is the eye color accent. Very, very cool fixture. It's a frosted tube. It looks like neon. It's probably about 1.5 inches thick, the actual tube itself. It's 120 volts. You don't need any power supplies, but it runs both power and data down through the fixture every 1.2 inches. So every 1.2 inches is actually controllable. So if you wanted to play video through this, if you put these on a vertical grid or any kind of grid, you can actually put media and play video through this particular fixture when you have many of them. One of the best examples is the next two application shots here. The first one is a chandelier built for the Tommy Hilfiger stores. This is a 6-foot-tall chandelier. It's a 3-dimensional chandelier that actually plays video through it. And the video they're playing is not like your typical video you see on a TV screen, but there's morphing images across all these tubes to have a 3-dimensional chandelier. It's down in New York City. It looks unbelievable. If you have a chance to go down there and take a look sometime, it's really, really cool in person.
Yeah, I think the next one is the coolest of all, though.
Yeah, this next one is unbelievable. This is the Harrah's Atlantic City Casino. Pretty over the top, as you'd imagine. It's a 40-story casino, brand new, just opened up this past summer. It has 35,000 linear feet of product wrapped around every single floor. So there's 7 miles of product Everything's addressable in every 1.2 inches, so it's pretty much a 40-story jumbotron, and it can be seen from 5 or 6 miles away. These two pictures don't do it justice, but it's very, 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 very impressive. They have, like, floating dice, and they have, like, fireworks going across the building and things like that, but very, very cool. So all 4 sides have this lit on the sides, the eye-color accent picture.
For anybody who's driven down to Atlantic City, you know how far away the interstate is from the casinos. I mean, you're talking miles, and you can literally see this video running from miles away. Matter of fact, from that distance, it's a lot higher resolution because the close. Yeah, exactly. Yeah, from a distance like that, it all comes together, and it's just amazing. I mean, we're lucky here because I'm on the East Coast, so I get to drive down there, and I've gone through there at night.
Yeah. Next slide.
Sure.
This is the eye-color Flex product. It's the same product we use for the Boathouse Road in Philadelphia. Each one of these little lights, they look like Christmas tree lights, but they're all individually programmed to be any color of the spectrum. So you can actually say, I want little light number 1 and light number 2 to be different colors. And if you put it on a grid, just like I mentioned before, it can play video through it. A company called Mainlight out of, I think it's Maryland or Delaware, they use this exact string or technology inside their curtains. So they're playing low-resolution video in a curtain that's made, and you can do that in an architectural application as well. And you can see the next photo here shows this is a nightclub in London where the entire place is lit by these string lights, and they're just they're pumping video through a media server and allows it to be a low-resolution video screen. I haven't seen it in person, but I guess it's unbelievable. But just think of things like that. You can do some of these things where you build architectural features around the lights, and it can be something very, very, very cool. Next slide.
Yep.
Some of the white light technology here, and we're almost done here. We're getting into the white light space. This is a brand new fixture. I didn't put new on the slide, but brand new fixture, fairly inexpensive. It comes in just 2 color temperatures, warm white and cool white, 2,700 or 4,000. Lasts 50,000 hours. It takes direct 120. There's no power supplies, no ballast, no data enablers. If you have a junction box that's got 120 there, you attach the wires, it turns right on, full intensity. Very exciting product for us. The next slide is going to show you the same picture from the Custom House Tower, which looks unbelievable in person. I live in Boston and I see it every day. The photo, unfortunately, could be better, a little bit blurry. But that third of the building is actually 18 stories tall. And there's 115 of those little black fixtures throughout the entire top of that building, lighting it up. So they save themselves 67% on their energy bill by changing over to an LED system, and they don't have to worry about going up there ever to change out the light bulbs for the foreseeable future. It is on a time clock. It goes on and off. I think it's only on for 6 or 7 hours a day. So they should have this up and running for 15, 20 years, no problem at all.
Now, one of the questions you knew was going to get asked when you said it was fairly inexpensive is, what's fairly inexpensive?
It's probably just about $500 the list price for it.
Yeah, so it's real cost effective, and the thing that people need to take into consideration is over the lifetime of the fixture, the cost savings in lower energy, the not having to switch out lamps on a consistent basis, and when you're talking outdoors like this with traditional lighting, you've got a lot of swapping going on. There's a lot of things, and the fact that you don't have to have anybody, the hourly wage thing of having anybody going up to have to change things out, that's a major thing as well.
Absolutely.
The question is this line voltage fixture dimmable? Are they able to dim it?
This one is not. Actually, the other ones I'm going to show you, the 2 or 3 I have left, are dimmable. This one right now, as is on-off. That's it. It's on-off. Here's the thing. We wanted to come out with a demo one. It was going to take us too long to get it out. So the first version of it, at least for the next year, is going to be just on-off. It will be dimmable. This fixture called the EW Grays, which is also in that building, I can't really point out where it's lighting up there. This is dimmable. This is a white light fixture, same color temperatures, warm and cool, 2,700 and 4,000. It's a grazing light, exterior rated grazing light. So it can light up the sides of the buildings by putting it right next to a surface. Very nice light source. Again, 120 volt. It's dimmable via an electronic low voltage dimmer. So an ELV dimmer, you know, if you the ETC or any electronic low voltage dimmer, even though it's 120 volt, if you use an ELV dimmer, it'll run these fixtures and dim them to about 20-25%. But a very, very nice fixture. I don't have any application software with this besides the custom house. I just can't point out where I can point out, but I can't point it out on the computer screen.
Gotcha.
Next, okay, EW Cove Power Core. It's been out for about a year and a half. Very, it's a nice fixture. It's wherever you are using incandescent sources. If you're using a xenon or a click strip or those Lumaline fixtures for your coves, this fixture, it only draws 5 watts per foot. That's it, 5 watts per foot, and it's 120 volt. There's no power supply. The actual, on the bottom part of that fixture, the power splice is included in there. So you can run up to 100 linear feet of product up to, I want to say, 200 feet away from your feed. And you can dim it using an ELV dimmer. So an electronic low voltage dimmer will allow you to dim it. The next picture will show you exactly what it can do. Even though it's a 1-foot section, you can connect many of them together end to end. This is the Old North Church in Boston. If you go on our website, you'll see a case study on this. They had an incandescent linear fixture light source called a Lumaline. It drew 28 watts per linear foot. That's what they were using before. This is now drawing just over 5 watts per foot, and it lasts them substantially longer. These particular fixtures are in a really tough location to get to, so when they have the incandescent linear fixture there, it was a lot of time and effort to get up there and change them, so they actually didn't even leave the fixtures on. They wouldn't even turn the lights on because it took so much effort to change the lights out. So once they changed to an LED system, they're now using them all the time. And again, it's on a standard electronic low voltage dimmer to dim down in that particular church. But it came out very, very, very nice. Next.
Okay. We had a real interested audience, and we had a lot of material to be covered. So we did run over. I just wanted to see if there's any last-minute questions. We're only going to be able to field a couple. We'll also try to get back with anybody that hasn't had their questions answered. We've had they've been rifling by, so I haven't been able to keep up with all of them, and I apologize for that. So anybody have any other general questions? Okay, let's see. We have one here that's, what's the recyclability of these units? For one thing, thankfully to this point, we don't have that as an issue yet because they haven't been out there long enough and they do have such a long lifespan. But what kind of recycle issues are we talking about, John? Do we have any feedback on that compared to?
That's a great question. Initially, in our first builds of our products and our designs, we didn't take into account too much in regards to recyclability. Our first versions of our Colorblast were actually glued. The boards themselves were glued on the aluminum housing. Every fixture we've come out with in the last year and a half is made with the full intent of being able to take the fixtures apart and recycle them. So as of today, Kinetics does not have a depot, per se, to recycle them directly to us. We are working on that. It's something that's one of the main initiatives we have. But the fixtures that we have that we're making now are all going to be pulled apart. That gray fixture is only 3 components: the power supply, the housing, and the lamp, the LED module itself. The new Colorblast housings, the ones that look kind of like an iMac, those can all be taken apart as well. And the injection molding on the actual EW Cove product, too, can be taken into 3 different parts. So we are taking it very, very seriously. We didn't take it nearly as seriously a few years ago, but going forward, that's definitely something we're going to be doing.
Okay, couple other questions. Are you thinking of a wider beam angle fixture for the Sykes? I'm assuming he means the blazes. Any new things coming out in terms of lenses or things of that nature?
Well, we're going to be coming out late next year. We're going to be coming out with a new version of that fixture. It's going to have red, green, blue, amber, and white LEDs. It'll be out probably in August or September of next year, which is very, very exciting. Some people have asked us that for a little while. But in regards to lensing, it does come with a 10-degree beam, but you can buy accessories, I believe, from City Theatrical, I think they're. I think they have lenses that allow you to have a wider beam on there. I'm almost certain they do, and I think they're glass as well. But you can make it a little wider.
Yeah, City Theatrical has a whole line of accessory products, including, we've had questions about how does this compare to traditional fixtures. City Theatrical has a whole series of barn doors and other types of fixtures that you would normally anticipate, with park hands and things of that nature, that you can use in this type to give you a more, quote, traditional entertainment or theatrical kind of application.
Mm-hmm.
Okay. Last question, are you thinking about 16-bit per color control on the color blades for greater control?
16-bit. So right now we run our fixtures at 8-bit. We've heard that. We have heard people asking about that. It doesn't happen too often for us. Right now, at least the current version of the blazes, at least until we come out with the RGBAW, it will not be 16-bit. I think it might be a little bit misleading on the bit control. From my understanding, at least, is that I'm not sure if it's on the front end or on the back end of the fixture itself. Even though it's called 8-bit, I think it actually it performs better than that for some reason. I'm not sure if it's closer to 12-bit or just 16-bit. But right now we're right now at 8-bit, and I don't know the next time I'm going to change to 16-bit.
Okay.
We used to make a Cove fixture for planetariums that was 16-bit because they, on the very, very, very low levels, they had to have that 16-bit control and those very, very dark applications. So we have made it in the past. I'm not sure why we don't do it in all of our fixtures. It must have something to do with some kind of technical challenge that we may have in engineering why we don't do 16-bit. But that's just off the top of my head.
Okay. Now, the one thing I did want to mention, there's been a lot of questions about the availability of this presentation. It's not available as a PowerPoint, but it will be available as a podcast on the Creative Stage Lighting website, as are the other previous webinars that we've done. So each one of these is recorded, will be available for download, and you can access that information just by going to the website that's at the bottom of your screen right now, www.creativestagelighting.com. If you do have any additional questions, you can send them to me at kevin@creativestagelighting.com, and I'll be glad to get you answers. And we will be trying to respond to any of the questions that got brought by us today that might still require answers. Okay? So we thank you all for attending. We really appreciate everybody being so attentive and having so many interesting and informative questions. And we look forward to seeing you at future editions of the Creative Stage Lighting webinar series. John, we want to thank you very much for an excellent presentation.
Thanks for having me.
Okay, great. All right, thanks everyone, and everyone have a very happy holidays, and we'll be seeing you in the new year with a new webinar in January. Thanks very much. Take care now.